Here we have the Samsung Galaxy Fold and the Motorola Razr, and these are two of the latest foldable smartphones. In this video, we will learn about the mechanisms and technology that make foldable smartphones possible. This video will focus on the mechanisms inside the Samsung Galaxy Fold, as I have yet to model the interior elements of the Motorola Razr, but both use similar foldable screen technology. As you may know, the Samsung Galaxy Fold had some major design flaws, and there are many videos that talk about these flaws as well as how it breaks. So instead, in order to better understand foldable smartphones, I'll show you how it was designed to work. First, we will explore the engineering behind the hinge, and then second, the technology in the layers of the flexible display. And after that, in order to fix some of the issues with these phones, I'll give you a conceptual redesign and my take on a foldable smartphone. So let's jump right in. Okay, first let's look at the hinge. It's not like a door hinge with two leaves held together by a pin, but rather the hinge somewhat resembles the folding of a hardcover book, as it has a spine with the left side and right side. After removing the back cover of the spine, you can see the internal mechanisms. At the top and bottom, we have the hinges that connect the spine to each side. Also along the spine, we have a set of 4 latches with buttons and springs on one side, and then holes on the other. When this phone is fully opened, the buttons click into the holes, thus preventing it from folding closed without a small amount of force. This feature gives the phone more rigidity and makes it feel more like a tablet when fully open. Next, we have a pair of flat cables that allow the left and right sides to communicate with one another. And finally, in the middle we have a unique set of gears and a partial metal bushing or motion guide. This guide helps to control the motion of the two sides and prevents any twisting from left to right. Finally, these gears make sure that the two sides open symmetrically. By that, I mean when opening, these two angles will remain equal, like the wings of a butterfly, which makes for a more aesthetically pleasing opening and closing feel. Moving on to the foldable screen. In here are a variety of layers. On top is a protective laminate, then clear capacitive touchscreen wires, and then an AMOLED display. I made a video that goes into exactly how the main layers of the touchscreen display work, and you should check it out. This screen is kinda similar, with the key difference that the foldable AMOLED display doesn't have protective glass, but rather it has a protective laminate on top, which is significantly softer than glass, but it does allow the phone to bend. The other key difference is that while the AMOLED display is manufactured on top of a thin, flexible metallic foil, behind the foil is a layer of plastic and foam, and behind that is a solid metal layer with an accordion-like hinge along the fold. This is called a living hinge, and it allows for bending along the center of the display. This smartphone has some rather innovative elements, but it needed a lot more rigorous durability testing and a few more redesigns during prototyping, which I'm sure was cut short due to the rush to be first to market. So let's move on. Here's my conceptual redesign and take on a foldable smartphone. First, I would separate the two screens into a primary and a secondary screen, and use a cylindrical hollow hinge with wires running through the inside. This hinge is similar to those used on the Nintendo DS, a wide variety of laptops, and flip phones, and it would be sealable from dirt, dust, and possibly water. Although the primary and secondary screens would be separated, there would be a lot of opportunity to develop apps to utilize both halves, and two separate screens would be more conducive to multitasking. The primary side of the phone would act as a normal smartphone, and the secondary side would be composed of several transparent layers. These transparent layers would be as follows: toughened glass, a capacitive touchscreen, an AMOLED display, a layer of polymer dispersed liquid crystal, a layer of aluminum oxynitride, and then another touchscreen and toughened glass. You know what these layers do, but this one, the polymer dispersed liquid crystal, is an electrically controlled clear or opaque glass. This material is used to turn conference room glass windows from clear to opaque. Then this layer, the aluminum oxynitride, also called ALON or transparent aluminum, will provide strength and structural rigidity, as it is the same material that is used as bulletproof glass on armored vehicles. So now that we understand the layers, let's go through some functionality. When the smartphone is closed and the secondary screen is folded on top of the primary screen, the secondary screen will be fully transparent. the touchscreen on the back of the secondary screen will operate the primary screen, and then the phone will operate like a normal smartphone. When the secondary screen is flipped open, the middle layer of polymer dispersed liquid crystal will turn it opaque, and the secondary screen will function as an additional touchscreen display. What are your thoughts on this concept of a foldable smartphone? Tell me in the comments below. That wraps it up for this episode. I'd like to thank Zach from the channel JerryRig Everything for providing me with images that were a big help in modeling this phone. His channel was one of the inspirations for my channel, and in it he does reviews, durability tests, and teardowns for a wide variety of smartphones and tech. This episode branches to prototyping, durability testing, and touchscreen displays. Thanks for watching. Until next time, consider the conceptual simplicity, yet structural complexity in the world around us.